So, as a part of learning basics of deep learning, today I am going to explain the basics of classification in machine learning, where we will understand what classification is, how it works, the different types, and where it is used in the real life. Now, let's see some introduction to classification and how it works and all. Classification is a supervised machine learning technique used to predict labels or categories. The goal is simple: take an input and decide which class it belongs to. For example, a model can look at an email and classify it as spam or not spam, or it can analyze an image and decide whether it's a dog or cat. Let's see. Here is a simple example. Suppose we train a model with images labeled as dogs or cats. This model learns patterns, color, texture, shape, and size. When a new image comes, the model checks its features and predicts whether it's a dog or a cat. Next is decision boundary. In the visualization, the x-axis represents combined color texture features and the y-axis shows shape and size features. Each dot is an image. Dot of one color represent dog predictions and the other represent cat. The shaded region shows the decision boundary. The dividing line the model uses to separate the dogs from cats. Let's see some types of classification. Classification problems can be of different types depending on the number of classes and how the data is labeled here. So the first one would be a binary classification. This is a simple type, only two classes. For example, classifying emails as spam or not spam. The model decides between two options. Second one is multi-class classification. In multi-class classification, we have more than two classes. For example, an image classifier that identifies whether the picture is a dog, cat, or bird. Here we can see the graph, the difference between which is a graph representing both binary classification and multi-class classification, where here are only two categories, where more than two categories it is called as multi-class classification. And next one is multi-label classification. In multi-label classification, one data point can belong to multiple categories simultaneously. So a movie can be tagged as both action and comedy. This is different from multi-class problems where each item has only one class. So where there is a common between the two categories, then it is called as multi-label classification. Now let's come to how classification works. Classification takes place in few steps. Let's have a few steps. Let's have a small overview of these steps. The first one is data collection. It gathers the label data. Next one is feature extraction. It identifies useful features like color or shape. Next one is model training. Algorithm learns patterns from label data. Next one is model evaluation. Test the model on unseen data. Next one is prediction. Use the trained model to classify new data. Next one is improvement. Tune hyperparameters if accuracy is not satisfactory. Uh, these are the six or classification works that helpful very much. And let's see some classification algorithms. To build classification models, several algorithms are available. They are mainly categorized as linear or non-linear classifiers. In linear classifiers create a straight line decision boundary. They are simple and efficient. And examples of a classification algorithms include super vendor machine, SO, SVM, and single layer perception, SGD classifier, logistic regression. The non-linear classifiers handle more complex patterns. Some popular non-linear models are k-nearest neighbors, kernel SVM, naive Bayes, decision trees, neural networks, assemble methods like random forest, data boost, bagging, voting classifier, extract trees, and many more. Let's see some real-time examples of classification in machine learning. Classification is used everywhere around us. Some real-world applications include email spam detection, credit risk prediction, medical diagnosis, image classification for security and autonomous vehicles, sentiment analysis, fraud detection, recommendation systems like Netflix and Amazon. So, based upon these all classifications, methods, types, let's have a small conclusion. Classification is powerful because it helps machines make decisions based on patterns in data. It has applications in almost every industry, from healthcare to finance, retail, entertainment, and beyond.